Hey everybody, Jason Blaha here with Ice Cream Fitness. Today I want to answer a Q&A. I had one of my subscribers ask me if I could go into a little more detail discussing the differences between myofibrillar hypertrophy and sarcoplasmic hypertrophy. But hold on, let me give you guys a tricep shot first. Been working pretty hard on my triceps lately, so I want to show them off a little bit. Okay, now on to different types of hypertrophy. He not only wanted me to address the difference between these two, but to discuss different training methods to stimulate a priority towards each type of hypertrophy. But first, let me kind of explain the difference. When we're discussing those two types of basic muscle hypertrophy, which we do know exist, myofibrillar hypertrophy is the actual hypertrophying of the contractile proteins, on the end of your muscle cells, that, the actin and myosin that engage together. And it's more of the direct functional hypertrophy in terms of actual force generation. Whereas in sarcoplasmic hypertrophy is the growth of the cytoplasm, the organelles, the various cellular structures inside the muscle cells. And it's a little bit less functional. It might offer some leverage advantages, but it doesn't necessarily directly contribute to force generation. The problem with the idea of training for different types, I think it's a really elegant theory, this idea that different training styles can have a different impact on the ratio of myofibrillar to sarcoplasmic growth. The problem is that it's still kind of bro science, meaning it's a theory that's been espoused by a lot of experts, and I think even Mark Ripto and others have hit upon it in some of their books. But the issue there is that we've never definitively shown in any research that within a given individual that changing training style changes the ratio of one to the other. Some people will tend to gain slightly different ratios than others in regards to myofibrillar versus sarcoplasmic growth, but we can't seem to replicate in a lab how a change in style of training or rep ranges or type of methods used will directly contribute to a different ratio in the gain of one versus the other. So again, it's still a bit of bro science, and it seems to be a popular way to describe why you see a strength difference between powerlifters and bodybuilders. And I think, and most experts, I think, agree on this one, and most exercise scientists agree on this one, that there are better explanations for this discrepancy we oftentimes see in size and strength than it being myofibrillar versus sarcoplasmic growth. The number one explanation that we have for that as far as the strength gain is that powerlifters and strength athletes train for speed and strength and explosiveness, and so therefore they have higher neural efficiencies. They have different types of rate coding as far as recruiting muscle fibers and motor units, and therefore they're going to have completely different force generation than someone who is trained in a manner that gives them less neural efficiency. Whereas in a lot of bodybuilders who train almost exclusively with higher reps and not so much training towards neural efficiency, are oftentimes much weaker but larger, and it's not to say that they wouldn't be even stronger than the powerlifters if they went and took their muscle mass and trained to use it more efficiently and to recruit motor units faster, because they have more tissue hypertrophy with which to work. They just don't use it very efficiently. And by that same token, because a lot of powerlifters who are still smaller, because they're able to generate so much neural efficiency, that tends to carry over to their higher rep work. And if they were to go in and do a bunch of hypertrophy-based training, even if it's something like 5x5, not even really high reps, they tend to grow extremely fast as a result of that. So because they're able to generate higher workloads. So they still have the ability as a result of that strength to gain muscle extremely rapidly. And by that same token, the larger bodybuilders could take the muscle mass that they have, learn to use it more efficiently, and a lot of them can be brutally strong, like you saw with guys like Ronnie Coleman. So I think that the neural efficiency and the motor unit recruitment pattern explains much of that. Then you have the other factor of what we would call transient storage factors. And and it's true, and we know this, and it's oftentimes pre-contest training focuses very heavy upon, or even pre-photo shoot training focuses very heavy in many bodybuilders upon training for a little more transient storage factors, which means storing primarily more glucose in the muscle cells for muscle glycogen, triglyceride storage, and things like that will tend to draw more fluid into the muscle, help it pump up and look more fuller, but it's not actual true tissue growth. And on the other hand, it's not infinite, meaning you can train for additional storage factors, and you're going to get some of those from doing, heavier work also, just not quite as much. And it's not to say that you're going to gain inches and inches of muscle doing this. It can help you train a muscle to appear a little fuller, but it's not going to be an infinite growth, meaning if you have a given amount of hypertrophy, you're not going to be able to keep that amount of hypertrophy without inducing more and gain an infinite amount of muscle glycogen. There are going to be finite limits. It's just that if you incorporate a bit of metabolic work, you're able to train these storage factors to make it appear just a little fuller. And it's also important to note that, again, they're called transient storage factors for a reason. They don't last very long. You can train in this manner, and when you cease training in this manner, within a few weeks, it disappears. This factor tends to detrain more quickly than you would actually lose true tissue hypertrophy. So it isn't quite as lasting, but it is something to consider, and it is one of the benefits of doing the more metabolic work when you just want to look bigger and fuller, but it shouldn't necessarily incorporate a huge amount of your training. And so really that's kind of an explanation of why you see this discrepancy sometimes between the size and strength ratios of a lot of bodybuilders versus power lifters, Olympic lifters, and strength athletes. And it's technique, neural efficiency, things like that. Not so much a difference in myofibrillar versus sarcoplasmic growth. And so for the layman who's not interested in studying the science of it for their own fun or amusement, or just to know, or they're not actual exercise scientists who make their living studying these things, it's not really that important for the layperson to know the difference between these two types of hypertrophy and how they function, because quite frankly it will have no real application to you in the real world. And I hope this has been beneficial for you. Let me give you guys another tricep shot. And that's all I have to say on that today. I'll talk to you next time.